Hi guys, and welcome to this, my video on factorising the difference of perfect squares. And you're going to say, that sounds mildly familiar. It sort of does. My name is Darren from Maths Guru. Thank you very much for joining me. Hopefully this video and the others that can be found at, maffsguru.com and on my YouTube channel will be useful. All right, they're there to try and help you smash Year 9 Maths or whatever year you are currently doing. Now, the only thing I'm going to ask before I get started is, can you head over to YouTube and subscribe to my YouTube channel? And you're going to say, why would I do that? Well, basically very few people watch my videos, and so every time someone subscribes it makes me feel really like, well, actually continuing recording them. I know some people enjoy these videos, and every time someone subscribes it just makes me want to continue, really, because then I know, oh, hold on a moment, someone has actually watched my videos. Right, so having done the whole needy stuff, let's going. I would normally have gone through the learning objectives, guys, but if you need to, just stop the video and watch it, all right, or read over it. Hopefully that will give you an indication of what I'm going to do. But let's get into this. In the last video, we did about factorization. Now, if you remember, factorization seems to be where we move the highest common factor outside of a set of brackets. Yeah, and if we looked at this as an example, we got 40 minus 16b was the very first example I think I dealt with, or certainly one of them. And again, I said to people, how many terms have you got? You got 2 terms. What is the highest common factor? Let's look at the numbers first of 40 and 16. Well, 8 seems to be the highest common factor of the numbers. Now let's look at the letters. Are there any letters that are shared between each of my terms? Well, obviously that's got a B in it. That doesn't have a B in it. So I draw a set of brackets. Now, believe it or not, it's the brackets that seem to be the most important thing here about factorization, and I'll come back to that in just a second. So 8 multiplied by what gives me 40? That will be 5. So a 5 goes in there. 8 multiplied by what gives me minus 16b? Well, 8 times negative 2 will give me negative 16, and then the b will just be there. So that's factorization. And there are obviously other ways of doing this. 40 minus 16b. If I write my 8 outside a set of brackets, what I'm really doing is I'm dividing each of these terms by 8. So 8's going to there once, 8 goes into there 5 times, 8 goes into there once, 8 goes into there twice. And again, there's no one way of doing maths. So what do we get left on the top? Well, we got the 5 minus 2 times b, 5 minus 2 times b, 5 minus 2b. So there are different ways of doing this. And in the video before that, we looked at the difference of perfect squares. And again, we're going to build on that a little bit more in just a moment. But factorization is huge in the Year 9 course. And I like to think of it really as moving stuff outside of a set of brackets. Now, way back in the first video, what did we have? We actually had binomial products, x plus 2, x minus 3. Yeah, so where we had a bracket multiplied by a bracket, and effectively that has been factorized, right? Because I've got a set of brackets times a set of brackets, we have factorized. And if we go back to the last video, we did some of those examples as well. Right, that's the recap of the past learning. Right, so let's recap DOPS. Difference of perfect squares. Difference means minus. Perfect squares are numbers that can be written as a power of floaty 2. So if we looked here, we found in a previous video, and if you're going to say what previous video, hey, maffsguru.com, head over there, you can have a look. But in a previous video, we found that when a set of brackets multiplied by each other, so binomial products, started with the same letter, ended with the same number, and were only different by a plus and a minus, then basically we ended up with this perfect square. So x squared minus 4 can be written as x in brackets squared minus 2 in brackets squared. Okay, so that became really important because these are difference of perfect squares. There is a perfect square, and now there is a perfect square, and there is my difference. All right, so but the videos we dealt previously went just in one way, and I know I showed actually the backtracking as well, but that's what this video is about. We said, oh, well, okay, we now notice that, for example, if I had 2x minus 3 and 2x plus 3, I can shortcut this. And I don't like shortcuts, they make me nervous. But I can already recognize that that and that are the same. The 3 and the 3 are the same. And the only thing that's different is the plus and the minus, which means I can shortcut this by writing the first term in a squared minus the second term in a squared. All right, so again, the 2x here was the 2x. I wrote it at a floaty 2. And the minus 3, or the 3, went in there with a floaty 2. And then I just simplified it. 2x squared is 4x squared. Oh, he says writing in equals, minus, and 9. So can we do this backwards? Well, of course we can do it backwards. Whenever they give me a question that has two perfect squares in it, or two things that I could write as perfect squares, then I can then factorize. And again, remember, factorize is writing stuff in sets of brackets. So if I go from 4x squared minus 9 to this, I have factorized it. Oh, here we go. So this is the formal theory, all right? And I know some teachers out there get very excited about teaching this, but what they're trying to say is, if I have a perfect square minus a different perfect square, I can write it inside the set of brackets by saying a plus b and a minus b, he says with an itchy eye. All right, so bear with me. Commercial break. Let's do some examples, and hopefully with the examples you'll suddenly go, oh yeah, this will make now perfect sense. So what do we got here? We've got x squared minus 4. So the first thing I'm going to say is, do you have two things minused from each other? So the chances are, if it's got an x squared in it and it's minusing another number, this is a DOPS question. Right. Are they currently written as perfect squares? No, because remember, as perfect squares, I've got to have something squared minus something squared. So the first thing I'm going to do is I'm going to say, well, okay, that's now x squared, because x with the brackets all squared, minus what number multiplied by itself gives 4? It's 2. So there is 2 squared. I've now written it as the difference of two perfect squares. And now I can use that little shortcut that we learned a moment ago, that says, when it's in this way, this letter here goes at the start of my set of brackets. So I can now write the x at the start of the brackets. I can write that 2 at the end of a set of brackets. And what goes in between them? Absolutely, one becomes a plus and one becomes a minus. And ka-ching, I have just factorized a DOPS expression. Oh my goodness, this stuff is amazing. All right, so that was the first one. Now look at the next one. We've got 9a squared minus 25. Remember, we got to write this in a difference of perfect squared. 9a squared. What multiplied by itself will give 9a squared? Well, we know that 3 times 3 is going to give me 9, so that can go inside my brackets. A times a gives me the a squared. And there we go. So let's just check. 3a times 3a is 9a squared. Minus, what multiplies by itself to give 25? Oh, 5. And there's my squared. So I've done all the hard work. There is my DOPS. Let's change color just because I can. The 3a goes at the start of the brackets. The 5 goes at the end of the brackets. And what goes between the two? One of them has to be a plus and one of them has to be a minus. You guys are amazing at this. And now I'm talking as if you're actually out there. Let's try again. I've got 81 x squared minus y squared. They're not written as DOPS yet, are they? No. So let's do that. We've got brackets minus brackets, put a square there and a square there. Right. Something times itself gives me 81. Well, that's got to be 9, because 9 times 9 is 81. Something times itself gives me x squared. Well, that's got to be an x. So there we go. So we've got 9x all squared minus, oh, that's easy, y. So again, there we go. I've got my difference of perfect squares. Let's change pen color again. So the 9x goes at the beginning of the brackets. The y goes at the end of the brackets. One is a plus and one is a minus. And if you understand that, and you've got that already, you are a gun of mathematics, or I'm a flipping good teacher. All right, factorize each of the following. Let's see. Let's do it a little bit quicker. Pause the video. See if you can get there first. Okay, it's not a race. It is a race. Life's not a competition. It is a competition. So what have we got here? We've got x squared minus 16. So x squared minus 16. Are they written in the right format at the moment? Nope. So I'm going to write some brackets with a squared minus some brackets with a squared. X times itself. Oh, that's got to be x. 16, what number multiplied by itself gives it? Oh yeah, I know, that's 4. And there we go, the hard work done. The rest of it is just writing in the brackets. So the first letter is an x, the first letter becomes an x. The 4's at the end, write the 4 at the end. Make one a plus, make one a minus, and we are done. Did you beat me? Of course you beat me, you managed to pause. Right, let me see, set of brackets squared, minus set of brackets squared. 4a squared. A number times by itself is going to give me 4. That's going to be 2. It's got to be an a. 9. A number multiplied by itself. Oh, it's got to be 3. And there we go. That's the hard part done. Write 2 sets of brackets. 2 a's at the front. So we write 2a at the front. 3's at the back. One has to be a plus. And one has to be a minus. God, change the pen color again. 25a squared minus b squared gives me brackets squared minus brackets squared. And again, the whole thing about these questions is, can you identify them, right? There are tricks coming up, but again, once you see past the tricks, it's the same over and over again. So what multiplied by itself gives me 25? Well, it has to be 5. And hopefully a, because a times a gives me the a squared. What multiplied by itself gives me b squared? It's got to be b. And there we go, we've done it again. So 5a is at the front, b is at the back, one's a plus and one's a minus. And there we go. I can't see how, outside of some other tricks, that this gets any harder. Now, what I'm trying to say here is that we can employ silly little tricks by asking you to factorize and then factorize again. So here is a perfect example. And sometimes you're going to have to factorize again. If we look at this example here, 2b squared minus 32. 2b squared minus 32. Well, 2 isn't a square number. 32 isn't a square number. But I've got a square term minus, or I've got something squared minus a number. It's too obvious. It looks... hold on a moment. I can go back to what I did in a previous video. If I look at this, what do I notice? Well, I've got a 2 and a 32. Those both factorize. The highest common factor of those is 2. So what I'm now going to do is I'm going to write the 2 outside of a set of brackets. All right, so 2 multiplied by what gives me 2b squared? Oh, it's got to be b squared. And 2 multiplied by what gives me negative 32? It's got to be negative 6. We've seen through the trick. And what do you notice now inside the set of brackets? I've suddenly got a perfect square. I've got a difference of perfect squares. Yeah, because I've got a b squared minus 16. Now, what I tend to do when I'm doing these questions is I tend to do a sub-calculation now, and I write over here b squared minus 16 is equal to b all squared minus what number multiplied by itself gives 16? 4. And I go, okay, so here's my sets of brackets. So that's b there and a b there, and a 4 there and a 4 there, and that's a plus and that's a minus. And there we go. I have factorized the b squared minus 16, and then all I'm going to do now is replace it. So where this once was, I can replace it with this, because they are effectively the same. So the 2 stays there. I write b plus 4 and b minus 4. And see what we've done here? We've started to combine the maths, and that's what maths does. We teach you all these basic skills and start to combine them to see if you can sort of pick them apart and sort of notice the patterns. And patterns are in maths all over the place. Right, other tricks. We get so used to using just one letter that when they throw in brackets and more than one letter, our brains get a bit confused. But the process works in exactly the same way. If we have a square term minus a square term, we are good. So here we go. A lot of people look at this and go, this is too hard. It isn't. DOPS says if you have a square term, so let me just write this out, x plus 1 squared minus 4. If you have a square term minus a square term, well, hold on a moment, I have a square term. It doesn't matter that it's got x plus 1 inside a set of brackets, it still works, because we've said a perfect square is something inside a set of brackets raised to a floaty 2. So can I turn that 4 into a power? Yes. So let's see, that's x plus 1 all squared minus 2 all squared. What's the next step? Well, you write 2 sets of brackets. So I'm going to write these slightly bigger. And then what do you do? Well, whatever was in the first set of brackets gets written at the front here, doesn't it? Right, well, okay then. So that becomes x plus 1. And that becomes x plus 1. Whatever was in the last set of brackets gets written at the end. So that becomes 2 and 2. And one of them becomes a plus, and one of them becomes a minus. And believe it or not, ka-ching, you've done it. Well, we have to do a little bit of simplifying, because we know that we can actually simplify 1 plus 2 and 1 minus 2. So in which case, that gives me x plus 3 and x minus 1. And ka-ching, we have factorized again. All right, so do you see the trick there? And that's what you've got to notice in tests and exams, because as maths teachers, that's pretty much what we're going to do to you all the time. I'm so sorry. Here's another example. Right, so you're in an exam now, you're studying this, you're going, oh my gosh, this looks hard. It says, no, it isn't, because what have we got here? We've got a square term, and we know that 9 can be written as a square term, so that's going to be x plus 2 all squared minus 3 squared. All right, do we have a square term minus a square term? We do. So the first thing gets written at the start of the brackets, x plus 2, x plus 2. The 3 gets written at the end, and 1 becomes a plus, and 1 becomes a minus. And then again, because we can simplify this, you always have to simplify it, because if you don't, unfortunately, you'll lose the mark. So plus 2 plus 3 is plus 5. Plus 2 minus 3 is minus 1. And again, we have factorized. I have written these in a set of brackets. And again, all of this actually has a purpose that we sort of deal with a little bit later on. Now, I know that in my lessons, I talk very much about sort of the graphs behind this. And I think I'm going to add at some point a video as to why we're doing all this stuff. Because I think it provides context for most of the work that we're doing. But when we have this type of thing here, that is nothing more than a graph, all right? So we can actually draw the graph of x plus 2 squared minus 9. So x plus 2 squared minus 9. Now, when I do this on a brilliant program called Desmos on desmos.com/calculator, this is what comes out. Now, I'm going to worry about the minus 5 or those two coordinates in just a moment. But I want you to look at that very bottom value there, the minimum point of that graph. Now, if I look at this here, it is minus 2, comma, minus 9. Hold on a moment. Minus 2, minus 9. Well, I've got a minus 9 there, but I've got a plus 2 there. And as it turns out, and again, I'm not going to get too deeply into this, these points here inside are actually our maximum or minimum point of our graph. We can actually, once we get our equation in this form, then we can actually find the minimum point of this. And if I actually complete the square of this, factorize this and do this as x plus 2 squared minus 3 squared, and that's going to give me x plus 2, close brackets, x plus 2, close brackets, 3 there, 3 there. One's a plus and one's a minus. And we get x plus 5. X minus 1, what do you suddenly notice about this? Well, that seems to have a minus 5 there, but a plus 5 in the brackets. That has a plus 1 there, but a minus 1 in the brackets. So again, what I'm trying to say is later on we're going to get to a point where we know that this factorized form here actually helps us find where it crosses the x-axis. So having it in this format gives us the minimum or maximum. Having it in this format helps us find my crossing points, my axes. And that's really why we factorize, to help us draw graphs. And believe it or not, that's where I'm going to leave this video. Hopefully it's been useful. Again, why are we doing this recap? That's really because I teach the students that I'm currently teaching a little bit more about the graphical stuff, but I may do a video on that a little bit later on. Hopefully it has been helpful. Please subscribe to my YouTube channel. Again, it just lets me know you're watching. There's Maths Guru, where all these notes and videos are, and hopefully I'll see you in another video. If not, you take care, guys. Take care.